It's Pi Day 2021. I'm sure that a lot of us remember back in third or fourth grade when we were sent home with an assignment to get out a glass and a tape measure and measure the diameter of the glass and then the circumference and divide one by the other. I went home and did that and announced to my mother that I had done the experiment and that it turned out to be about 3.1. And she told me that I'd done the experiment quite well, that the real answer was 3.1415926, and that actually the number goes on forever. Well, I was taken aback by that. Why would my mother know this number to such a high resolution? So I was really impressed with my mother, who was actually a high school math instructor, but I was also impressed with the fact that this was probably a fairly important number. Those of us who went on to have calculus learned that pi could be calculated by one of several techniques using infinite series, where we just added up a whole lot of terms to get pi to as high of resolution as we wanted to. But equations are no fun. My instructor in calculus also showed us a geometric way to calculate pi that we can look at in pictures. He tried to draw it on the blackboard. He didn't have the tools that we have today to demonstrate the idea, but that's what I'm going to show you here. This idea was invented by Archimedes in about the year 200. His idea was to approximate a circle with a polygon of n sides, and each part of the polygon was represented by a triangle. And if we increase the number of polygon sides and triangles, we get closer and closer to the circle, less error and less red shows. And what's cool is that we already know how to calculate the area of a triangle. So let's fire up our demo. What we have here is a circle that we're trying to approximate, and I have an inscribed four-sided polygon, and each of those sides has a triangle here that we can calculate the area of. And what I'm showing here is the total area that I've measured so far inside the square. Pi is the correct answer right here, and here is the error. And so what I'm going to do is start increasing the number of sides in the polygon. 5, 7, 9. And as we see, as we increase the number of polygon parts, the area outside the polygon is getting smaller. That is the error between the area of my polygon set and the circle. And as we continue on out, we see that we're starting to approach the right answer for pi. We're down to 1.5% error. And as I increase to 116 or so, 155, set it to 360 so that there is a polygon for every degree in the circle. And now we're seeing that we're getting significantly closer to our right answer. And I'm going to keep increasing the number, and we're turning our circle essentially black. And when I get up to 1100 or so, 1500, I'm getting a pretty darn good approximation to pi. So how many sides of our polygon, number of triangles do we need to get a good estimate of pi? Let's start increasing the number of points. 1500, 2000, 4,700, 8,500. You can see that the total area is getting closer and closer to the true value of pi. 11,000, 15,000, 27,000, 35,000, 47,000, and we're going to stop at 85,000. And at this point, what we see is that we get good agreement to 1, 2, 3, 4, 5, 6, 7, 8, 9 digits of the value. If we kept on going, we could get closer and closer, but I think we've proven our point. So we have split our pie up into 85,000 pieces, enough to feed San Francisco, although each person will only get a small piece of a cherry. But we're talking about math here and not talking about feeding populations. So I hope you've enjoyed this presentation and perhaps learned a little bit, gotten more appreciation for our friend Archimedes. And I'm just going to close with a few fun facts. In 2011, the Alabama legislature considered H.R. 205, the Geometric Simplification Act, declaring the Euclidean mathematical constant pi to be precisely 3. The objective being to make mathematics less confusing for Alabama students. And more importantly, on this day in 2015, the geeks at Google announced that they'd calculated pi to 31 trillion places. The proclamation did not say why they stopped there. Last, happy birthday to our favorite geek. Happy Pi Day.